This conference will now be recorded.
Hi all, good morning, good evening. Welcome to day one of JMeter Beginner to Master with Groovy, Dynatrace, Kubernetes, Docker, InfluxDB, Grafana, Jenkins, and BlazeMeter. I'm Chandra. I'm your trainer for the training session. So yesterday we had the demo session, right? And in which we went through the different topics which we are going to cover as part of this training. And then there were a good number of queries which were answered, and then we have started with the introduction, right? However, before I start for the day, are there any queries from anyone? Any queries from anyone from yesterday or from the course content?
Yesterday's session's recording is available.
Yes, I think it was shared.
Yes, but I am not participate, so I don't have any link.
Now, if you are present in the WhatsApp group, you should be having the recording link. If you
Okay,
joined late,
thanks. I will check.
maybe yeah, you please check the WhatsApp group. The recording link has already been posted in the WhatsApp group. Okay. Any other queries, anyone?
Okay.
Okay, all sounds good. So let us start for the day, guys. So I just gave an introduction to the different types of tests conducted as part of non-functional testing. Clear? So let me start sharing my screen. I hope my screen should be visible to all of you. So whenever you have any queries, please unmute yourself and ask your query, everyone. In case you do not have any query, I'll request you all to be on mute. Thank you. So can anyone confirm if my screen is visible?
Yes,
Yes,
your
sir.
screen is visible.
Okay,
Yes.
thank you. Thank you. So next we are going to see why performance testing is required. Means we are already doing functional testing, right? We are already verifying the functionality. But why performance testing is required? Okay. You know, previously the organizations, the enterprises, they were not giving that much of importance to performance testing. If you say like around 6, 7 years ago, that much importance was not given to performance testing. But with time, means because people are following waterfall model, the development would take a long time. The testing time would already be shrinked. Once functional testing is completed, the organizations, the projects were thinking that they could take the application to live. But with time, the importance of performance testing has been understood, and nowadays you will see that each and every project implements performance testing. So why this performance testing is required? Okay, the first parameter, which is required to be verified is the speed. You use any application, if the speed or if the application is not fast, right? Nowadays the users are very impatient, guys. The users are very impatient, they cannot wait, right? So if the speed of the application is not good, if the application is not fast, now what is the meaning of if the application is not speed, or if this application is not fast? Means whenever you are doing any user action or whenever you are doing any transaction, it should not keep you waiting, guys. The application, right? It should show the response. or it should show the next page, right, as soon as possible on your mobile device or on your desktop or on your laptop. So whichever device you are using to access the application, you should see the response as fast as possible. That is the application speed. So this speed is nothing but the rate at which the application is responding to your user action or your transactions. Okay, what is user action? I'll explain you. So that is speed, guys. The application, how fast the application is responding to the user. Okay, so that is speed. Next parameter which we need to verify is the scalability. Now you see, any application you take, the functional testing will be done with, like, how many functional testers will there be in a team? Hardly 4 5, right? 4 5 functional testers will be there. If they are concurrently using the application and doing the testing, so how much load is there on the application, guys? 4 to 5 users only, right? But when the application goes to production, when the application goes to production, you are not going to have only 4 5 users, right? There will not be only 4 5 users in production. Depending on the application, the number of users will vary, but definitely there will be more number of users. And in that case, if we are only doing the functional testing and sending the application to production, and during functional testing we observe that the speed of the application is very good, we cannot guarantee that the speed of the application will be good for 500 users. The speed of the application will be good for 1000 users, 5000 users, 10,000 users, and so on, right? Clear, all of you? So that is why we need to do performance testing to verify the performance with a higher user load. With a higher user load, the speed may be very good with, low number of users, but when the number of users are increased, the speed of the application should also cope up, or should also be able to, you know cater to that increased load. Now guys, take some examples, like during any festive sale. Okay, any e-commerce application you take, during the normal days, just from your imagination you think, during the normal days, when there is no festival, when there is no sale, so whatever is the number of users who are accessing the application, do you think the same number of users will access the application during any festive sale? In the normal days, whatever is the number of users accessing the application, do you think that the same number of users will use the application during a festive sale? What is your answer?
It will increase.
It will increase, and it will not be a mere increase of 5-10%, right? It could be twice, it could be thrice. Agree?
Yes.
Okay, that is one use case, guys. That is one use case. Next, I'll tell you. Today, a company is doing a project to launch a new application, right? So it has started a project. Now, the project will go live, or the application will go live, let's say after 1 year. The application will be designed to be able to handle a certain number of users. Agree? It will be able to handle a certain number of users. The design will be in that particular way. Now, guys, after 5 years, do you think the same number of users will be there on the application?
It will grow.
It will grow. And that is the
Yes.
objective of every business also to grow, right? For us, like whenever we are working in projects, that is only application for us, right? Which we are testing or which we are validating or which we are developing. But for the organization, for the enterprise, whoever is running that project, for them it is a business, right? It is a business. And every businessman wants to grow their business, right or wrong? Everyone wants to grow their business. How the business will grow? The business will grow with increased footfall or increased number of users. Clear? So every business wants to grow their number of users or their customer base basically. Now, I'm expecting after 4 years or after 5 years, my application, will have thrice the number of users with whatever is present today. Whatever is present today, after let's say 4 years, there will be the 3 times of the users. Now, in order to be able to cater to that, I cannot run a project each and every year, guys. Can the organization afford to design a new application every, year? No. There are some domains, you won't believe, there are some domains in which the companies do not invest in IT so much, guys. In utilities domain, you will find that they will invest in IT like, in 8 years, 10 years. They do not, invest much in IT. Like banking, financial services, these are, retail. They heavily invest in IT because they have to come up with new features every time. They have to attract their customers, right? Now, if I'm not going to invest in IT every year, so whatever application I am designing today, I have to design in such a way that after 4 years, when I have 3 times the number of users, it should be able to cater to that volume of users also. So what does this term say, guys? It should be scalable. My application should be scalable. It should be able to scale up. With the increase in the number of users, my application should be able to scale up, and this property is known as scalability. And when it is able to scale up, then also the performance should not degrade. Otherwise, if the performance is degrading after scaling up or after these many users have logged in into the application or are using the application, then I cannot say that my application is scalable because the performance has degraded. It was not able to cater to those many number of users. That is why scalability is also very important, guys. So we are going to verify. We're going to verify whether my application is scalable or not, whether it is able to, you know, provide good performance with increase in twice the number of users, with increase in thrice the number of users. So we are verifying speed, we are verifying scalability. Now let's assume that my application has very good speed. My application is scalable, but if that is for a short duration, over the longer period of time, the application is not able to provide good performance. So what does that mean? My application is not reliable. Clear, all of you? Over the longer duration of time, if my application is not able to provide good performance, I can say that my application is not reliable. So the other parameter which we are going to verify as part of performance testing is reliability. So taking these three factors into consideration, guys, these three parameters into consideration, we can say that we want to verify the speed of the application. The application should have good speed, it should be fast to respond, so the performance is good. Along with that, it should be able to scale up to provide good performance with increased number of users also. And this speed and scalability should remain in the application over longer durations of time. It should not be the case that it was having good speed, it was scalable for a smaller duration, and in the long run the application's performance degraded. Clear, all of you? So these are the three important parameters which we measure during performance testing. There are different types of tests which are conducted. Okay, there are different types of tests which are conducted to verify these parameters. We will see those tests as well. Okay, any queries, anyone?
Good morning, Chandra sir. I didn't understand reliability parameter. Can you please explain it with example?
Okay, banking application. Okay, banking servers. They have to be up and running 24 cross 7. They have to be up and running 24 cross 7, right? Now, let's say there is a batch job running. There is a batch job running every 15 minutes. Every 15 minutes, there will be a batch job running. Internet banking application, I understand that during the night or after the business hours, the number of users will decrease. But in the internal system of the bank, okay, just think that there is a batch job running every 15 minutes. Now, there will be a time taken to complete that batch job. Let's say if it is completed within 3 minutes. Okay, so and we have a SLA of 5 minutes. So okay, I'm introducing the term of SLA. Let's forget that. I'll explain you later. Let's say we want that it should get completed within 5 minutes. Our objective is that it should get completed within 5 minutes every time. So after, means 1 month, 2 months, 6 months, 8 months also, it should continue to complete within your 5 minutes. Okay, similarly, let's say there is a sale on an e-commerce application for 5 days. For 5 days there is a sale. So during that sale, guys, you will see increased number of users again. Let's say the sale started on the day 1, the performance was very good, the application was able to scale up. But then after, the performance started degrading. Then after, the performance started degrading in the last 4 days of the sale, from the second day onwards. So in that case, I cannot say that my application is reliable, because it was not able to provide the good performance over the longer duration of time. Now, what could be the reason? That is different. We will see that. What could be the reason for degradation of performance? That is a different case. But the point here is that it was not able to provide the good performance for longer durations of time. Understood? That is reliability. Means it was not reliable. Am I clear?
Okay, so yeah, clear. And I was about to ask the reasons, but you said you will explain it later. Thank you.
Thank you. Any other queries, anyone?
Yeah,
Why we need performance? Yeah.
yeah. Hi, Chandra. Just one query. So, as a seasoned performance engineer, like somebody like you, will you have a visibility of what scalability the organization is looking at, considering when they launch a new application, so down the line after say 5 years, what are the numbers
Yes,
we're gonna hit probably. So will you
yes.
have that visibility as somebody who has say more than a decade experience on performance engineering?
So it is, see, definitely experience helps, but as our, so we'll go to that. This is a very good question. Can I park this question for one more slide? Then when I go to that topic, I'll explain your answer. Okay? Means you
Sure.
will be able to relate to that. Okay? We'll come to your question. Any other queries? But that is a good question. Okay? I'll come to that. Any other queries, anyone? Perfect. So then we'll go to some of the common terminologies which we use in performance testing, because I'll be frequently using those terms, right? So if you are not aware of those terms, it will be difficult for you to catch up. Also, in the projects, whatever terms you will frequently hear when you are in a performance testing project. So let's go through them. So the first term, okay, the first term is the virtual user. Virtual user is, okay. We all are real users. We are using application. We are real users. Now I told you like functional testing is done with 4 or 5 users, right? But tomorrow I have to test the application with 5,000 users, 10,000 users, 1 million users, for example. Now forget 1 million, forget 10,000. Let's say 5,000 also. If I have to do a performance test with 5,000 users, do you think that I will hire 5,000 people, I will set up the infrastructure for them, and then ask them to do the tests? Is it really possible, guys? No, right? And even if I'm able to set up the infrastructure, even if I'm able to hire them to do my tests, it will be very difficult for me to coordinate among these 5,000 people. Their uniform, their behavior will not be the uniform. Behavior means their behavior to use the application. Their behavior to use the application will not be uniform. Human beings are prone to errors, right? Human beings are prone to errors, so they will create errors. So why will I go and do all those, things? Why will I get into that mesh? Understood, all of you? That is why we take the help of performance testing tools. Now, in performance testing tool, we have to generate users, right? We have to generate users. Those users will be using the application, or those users will be doing the transactions on the applications. Now, when I say users, guys, there will be some connections, there will be some threads. Okay, there will be some threads opened to the application, and those threads will be doing the transactions. Now, they cannot do the transactions on their own. They cannot do the transactions on their own. We will be telling to the tool, we will be telling to the performance testing tool that you have to do these transactions, and then the tool will tell the threads to do those transactions. So how that mechanism will work, I'll show you. But virtual user means the users which are generated by the performance testing tool to do the transactions. In other words, we are simulating the transactions. Okay, we are simulating the transactions with the help of virtual users. Am I clear, all of you? We are simulating the transactions with the help of virtual users. Next, response time. Response time. This term you will also find very frequently, guys. What is response time? So, what happens basically is, this is our client. You all understand client, right? This is our client. Okay, and client means the system of the user, guys. The system of the user. And then here, let's say we have the server. Server means our application server, where the application is hosted, right? You all understand the client server architecture, right? So server means where our application is hosted on the data centers, right? So whenever we are doing any transaction as a user, okay, whenever we are doing any transaction as a user, what happens, guys? What will happen basically? The Let's say you launch any URL. You launch any URL. On launching the URL, a request will go from the client to the server. Okay, a request will go from the client to the server. So this is my request. This is my request. Understood? A request will go to the server, and this is my request 1. Right? This is my request 1. Once this request goes to the server will process that request. The server will process that request based on the logic whatever is written, right? Your developers would have written the logic how a particular application, or how the application is going to handle a particular request. Then what will happen is, the once the server processes that request, it will basically it will basically one moment. So once the server processes that request, it will process that request, and then it will send the response. It will send the response back to the server, guys. Request 1, the request will be processed by the server. The response will come back to the client, and the client will see the response on the browser or mobile device, whatever is the client. Are all of you clear? Let's say I launch like Isha Training Solutions.org. So when you launch that particular URL, you see here, so if I launch Isha Training Solutions, right, .org, so when I launch Isha Training Solutions.org, you see it is taking some time to process, and then something has started to load on my browser, and I get the response, or the web page is displayed on my browser. Here all of you. So this is the response which I get from the server, and when I entered the URL, that was the request which I made to the server. Okay, I made the request to the server, then the server processed that, and I got the response back. Now it will take some time, guys. The server will take some time to process each and every request, and one and the time. So let's say the time taken by the server. Let's say the time taken by the server to process the request is X. Okay. the time taken by the server to process the request 1 is X, and then the response comes back. Who can tell me? I think you all should be aware, information is sent over the network in the form of bytes or data packets. I hope you all know that, right? Information is sent over the network in the form of data packets or bytes. Now this response, when it comes back to the client, it will also come in the form of bytes. It will also come in the form of bytes, right? Now when they have left the server, and then the time taken by the first byte, guys, so that response is coming in the form of bytes, right? So when the first byte reaches the client, there will also be a time taken by the first byte to reach the server. Clear? To reach the server. And what did I tell you? Time taken by the server, let's say, to process the request is X. Okay, so your response time is nothing but X plus Y. Your response time is nothing but X plus Y. It can be in milliseconds, it can be in seconds, it can be in minutes, it can be in hours, but minutes and hours are not actually expected. Okay, so what is response time? The time taken by the server to process the request, and time taken by the first byte to reach the server. Basically, it is a summation. It is a summation of the time taken by the server to process the request, as well as the time taken by the first byte to reach the client from the server. Did you all understand this?
Yes.
That is our response time. So what is expected, guys? The application should have less response time or high response time?
Less.
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 Anyone? Less. Okay. Anyone having the answer as high? Okay. So I think all of you are clear. For good performance, we need to have low response time or less response time, guys. Okay. Next, throughput. Throughput. The figure which I just showed, I showed you one request. So request 1 will go, the response of that request will come back. Now I launched the URL, the request would have gone to the server processed it. Now I'll not stop there, right? I will do the next transactions. I'll not stop there, I'll do the next transaction. So after request 1, I'll send request 2. After request 2, I'll send request 3. Till my business flow, till my user flow, till my scenario is completed, I'll keep on sending, or I'll keep on doing the transactions. Right? And that is for one user, guys. So when multiple users, or let's say one user also, when they are using the application, the request is going to the server. The request is going to the server. Now what is throughput? Throughput is basically the output of the server, guys. Throughput is the output of the server. Now if I have to define throughput, then it will be like the rate at which the number of requests are processed by the server, the rate at which the number of transactions are processed by the server. So the server will be processing the requests, the server will be processing the transactions. So the speed at which it is able to process those requests, those transactions, is called the throughput, or it is basically the output, right? Clear, all of you? It will be processing the requests, the speed at which it can do is throughput, or the number of requests which it can process is the throughput. Okay, the number of requests which it can process at a given point of time is your throughput. So the server, the application should have good throughput, guys. It should have good throughput. Okay, now can you tell me, just think guys, if my response time is less, throughput will be more or high? Sorry, throughput will be more or less? My bad, guys. If the
less.
response, if the response time is less, okay, if the response time is less, throughput will be high or low?
Hi.
I,
Okay. Any other answers? I heard one more answer was low, I believe. Response time is less, throughput will be high or less? Throughput is amount of requests processed by the server. If my throughput is high, if my throughput is high, it means the server is processing a lot of requests, right? If the throughput is high, it means the server is processing a lot of requests. If it is processing a lot of requests, what do you think? It would be taking more time to process the request, or it would be taking less time to process the request? If it is able to process a lot of requests, it would be taking less time to process the request, or high time to process the request, or more time to process the request? What do you think is? Very easy answer, I believe. If
Low
I'm
time.
able to, it would be taking low time, right? All of you. See, just compare that. I just compare that. There are two laborers doing the work. Okay, one laborer is able to complete more tasks. Another laborer is able to complete less tasks in the same duration. So the one who is able to complete more tasks is able to complete more tasks because it is doing those tasks faster, right? So if it is doing those tasks faster, for each task, that person would be taking less time to complete. Similarly, here also, if my application is processing, or if my server is processing a lot of requests in a given time, in that case, the time taken to process those requests would be less. So if the time taken to process the request is less, what will be the response time, high or low?
Low.
low.
All of you agree, guys? Low.
Yes.
So
No.
we conclude that throughput and response time are inversely proportional to each other. With increase in throughput, response time will decrease. With decrease in throughput, response time will increase. You have to remember this interview question, guys. Throughput and response time are inversely proportional to each other. I hope you all understood. Any queries?
So, do we measure the throughput in terms of the seconds? Like you mentioned that it is basically a rate at which the number of
Yes.
requests are
In
processed at.
general, in general, the throughput is measured in terms of seconds. Okay. However, you can get the requirements for the throughput in terms of hours, or in terms of minutes, or in terms of seconds. Ideally, the other term for throughput is nothing but transactions per second.
Okay.
Okay. Yeah. Next term is the request. I have already explained you what is the request. Whenever we are doing any transaction, right? Whenever we are doing any transaction in the backend, there will be a request going from the client to the server. Remember, request will go from the client to the server. Okay. Now for each transaction, there can be multiple requests also. I'll show you that in the future. Okay. For one transaction or for one action, for one action performed by the user, there could be multiple requests going to the server. It depends on the application, how it is designed. So do not assume that for one transaction there will be always one request only, guys. Okay, it is not the case. For one transaction there can be multiple requests going to the server. Response, I told you the server will process the request and send the response back. So the response is the response of the server. So response will always come from server, go to the client. Okay, request and response. Next, transaction. As I told you, one transaction can have one request or can have multiple requests. That is why I am differentiating them, guys. Now, whenever, let's say I want to do a scenario to book a flight, in order to book a flight, I have to launch the application, I have to log in into the application, I have to provide the source and destination and search my flight. Whatever options are displayed to me, that is the response, right, from the server. Whatever options are displayed to me, I will select the flight, then I will make the payment and I will book the ticket and then I will log out. So launch, login, right? Search flight, select flight, make payment, log out. These all are one transaction. These all are one transaction. Now when I'm doing these transactions in the backend, there can be multiple requests going to the server or single request going to the server for each transaction. Transaction is the granular action in your user flow, in your business flow. Understood? Clear, all of you? Every interaction of the client with the server will be called as transaction. So here comes transactions per second. Just a few minutes back, there was a question, right? That do we measure throughput in seconds? Yes, most ideally, we measure throughputs in the rate of seconds. So the transactions per second, this is basically the number of transactions happening per second, guys. So this is another term for throughput. Iteration. So now there is a new term called as iteration. So what is this iteration? Okay, before going to iteration, I want to tell one more relationship. Requests. Okay, requests are going to the server. Requests are going to the server. When more number of requests will go to the server, when more number of requests will go to the server, the throughput will increase or will decrease.
It depends, right? I mean, uh, it depends on how the load balancing has been done. If one server is taking care of all the transactions, then again it depends on how the architecture or uh, the hardware used at the server. If that is capable enough to handle that, or
Okay. Any other answers? What do you think? With the increase in the number of requests, what will happen to the throughput?
I think throughput will also increase because more number of requests, so more number of processes server has to do.
Okay. Any other answers? Any
Ideally, it
other
should not
answers?
increase, right?
Ideally, it should not increase throughput.
Right.
Okay. Okay. So, guys, I think the first answer was a bit more close, but he used some terms which people might not be aware. I'll explain you in layman language. It will depend on the performance of the application. If the performance of the application is good, if the performance of the application is good, it is expected that with increase in the number of requests, with increase in the number of requests, throughput should also increase. Please remember this. With the increase in number of requests, throughput should also increase. If so many requests are going to the server, and if the server is not able to process them, or it is taking more time to process them. So if it is taking more time to process them, it means your response time is increasing, right? It means your response time is increasing. So if response time is increasing, is the performance good or bad?
Bad.
Bad, right? So that is what my point is. For an application to provide good performance, okay, for an application to provide good performance, the throughput of the system should increase with the increase in the number of requests. Okay, throughput should increase with the increase in the number of requests. So remember this relationship again, guys. Means we will always look for good performance only, right? Our objective is good performance. So the relationship is that throughput and requests going to the server, that is nothing but hits per second, guys. Hits per second is the request, number of requests per second going to the server. So throughput and hits per second are directly proportional to each other. Throughput and hits per second are directly proportional to each other, but throughput and response time are inversely proportional to each other, and all these things will be valid for a good performing application, guys. For a good performing application. Clear, all of you? Are all of you
So,
clear?
yeah, isn't it this way that, say, if the server is designed to handle, say, 100 requests per second, so until the number of requests are, say, under 100, the throughput would remain same, and once it crosses a given threshold of 100, only then the threshold becomes directly proportional to the number of hits. Because if throughput increases with, say, the first number of a request, wouldn't that be a bottleneck for the performance? That, I mean, there has to be some threshold, and only beyond a threshold, the throughput should be directly proportional, right?
No, perhaps you did not understand my point. What is throughput? Processing of request, right? If my requests are increasing, the processing also should increase. That is what I wanted to say. If there are 10 requests, those 10 requests should be, means the way you are saying that if there is one request, I will, for one request or 10 requests or for 50 requests, I will have same kind of response time, or my system will do the processing, means at the same speed. Like for one request, whatever time it was taking, for 10 requests also, if it will process in that way, it will, the response time will increase 10 times, right? Are you getting
No, no.
my
My
point or
my
not?
point was, no, I got it. But my point is, like, even if we take an example of say multi processing at, or say system level, like if I have 10 applications open, say if the processor is designed to handle say three parallel applications, so simultaneously, like if I have an Outlook, if I have GoToMeeting. So if these two things are opened parallelly, then it will work fine. On top of that, if I add additional load, say opening an IntelliJ or a Postman, right? Now here is where it adds more load, right? So my point was, when they design a server, right? So they everything will have a threshold, right? Like say until it reaches 10 requests, the throughput needs to be same, and 10 is the threshold, and beyond, say, and once it crosses say 11th, 12th, and this is where we should see the increase in the throughput, right? Which is basically, this is how it should increase, right? Like it should not increase, say for one, if it is x, then for two, if it should not be x plus 1, it should remain x until 10, and beyond 10 it should increase. I mean,
No,
is my understanding.
that whatever you are explaining is a bit different. Here whatever I'm explaining, throughput is the rate at which it is processing the request, the rate, okay, per second, whatever request it has to process. Let's say initially per second 10 requests were going, and let's say the server is able to process 10 requests per second, okay. And if I go by your logic that my throughput has to remain same, throughput remains same means 10 requests per second, right?
Hmm. Right.
Now, for example, next I'm sending 50 requests per second, and if I have to, and because let's say I tell that my threshold is 100 requests per second only, so if my 50 requests will go per second, my, and if I will say that my server will process 10 requests per second only, so here my throughput is decreasing or not, because previously, means basically the requests will, throughput will decrease because the number of requests getting processed has decreased at any point of time. My earlier my 10 requests were going, it was processing 10 requests. Now 50 requests are going, it is not able to process 50, rather it is processing only 10 per second. So 40 requests are waiting for 10 requests to get completed. Then again 10 will process, 30 will wait, again 10 will process, 20 will wait. As a result, requests will get piled up, right, on the server, and my response time will increase. Did you understand?
Yeah, yeah, yeah.
So it is not the way you explained. So for a, for an application which has been designed to deliver optimum performance, the throughput should increase with the increase in number of requests. But yes, there is a caveat here, guys. Systems are designed, right? So they will have hardware and all. You cannot keep on bombarding the requests. Cannot keep on bombarding the request. They will always have a capacity, right? Like as he was mentioning about threshold, my server will have a capacity, will have a threshold value of processing a certain number of requests per second. Now if that is means if that limit is reached, and beyond that you see that number of requests are still increasing, then the throughput will remain constant, guys. Understood? Let's say my server will be able to process only 100 requests per second. 100 requests per second. Till the time I'm sending 100 requests, let's say I started with 10 requests per second, my performance is very good. I send 50, very good. I send 100, very good. But if when I'm trying to send beyond 100, beyond 100, my throughput will no more increase, guys, because the design of my server has been done in such a way that it can be able to process 100 requests per second only. So these are the behaviors which you will see during your test execution. Okay, that after a certain point of time, if your requests are increasing but your throughput has remained constant, then you can say that your capacity has been reached. But with increase in number of requests per second, if your throughput is decreasing, that is a different behavior again. With increase in number of requests, your throughput is decreasing. So if your throughput is decreasing, your response time will increase. Your response time will increase. There could be some bottlenecks. There could be some bottlenecks. There could be some major issue in the application, because of which throughput decreased with the increase in number of requests. The point I'm trying to explain is what is the desired behavior. Okay, in performance testing, what is the desired behavior? So if you see any deviation from the desired behavior, you can take the approach to investigate that. Because if my desired behavior is there, I do not need to investigate, right guys? Whatever I'm expecting in my execution, if that is happening, I do not need to investigate. Only when there are problems, I will investigate. Am I clear? You go for your blood tests, right? If the different parameters are normal, you simply say, yes, your body is healthy. You do not go for further investigations. Am I clear? But if there are deviations in your normal parameter values, then you go for further investigation. You go and visit a doctor. Am I clear, guys? Clear, all of you? I think we have reached the time for today. We'll stop here. So we'll start with iteration in the next session, guys. Thank you all for joining. Hope you all enjoyed the session.
Thank you, sir.
Thank you all.
That is